just lucky, right? In other words, you worked on the LFP, and now the market demand is
Well,
there.
the lucky is a prerequisite, but yeah, it's better if you've prepared.
Yeah.
I agree with that.
Bob Lee, welcome to At the Wheel. We're really glad you made some time to talk here at a busy conference on Mackinac.
Thank you very much for having me.
For the
Pleasure.
one or two listeners and viewers who might not know, you are the president of LG Energy Solutions in North America. As we're talking to you today, you just announced, you and DTE Energy just announced a large deal for energy storage.
Yep.
Tell us a little bit about that deal, and then kind of how it fits into the broader pivot that you've made here from EV batteries to energy storage.
Absolutely. So first, this deal, we're really excited about it because this is the first project we know where there's a ESS deployment in Michigan made with battery cells made in Michigan. So we've been working with DTE to make this happen. And as you may know, our Holland plant's been in existence for 13 years. And this is the first time we've been able to have products coming out of that plant for a project in Michigan. So it's really exciting, and we really appreciate DTE. And there were many stakeholders who made this happen. I would say, yeah, so that comes in the context of our overall pivot, converting some of our capacity from EV focused products to energy storage focused products. And that's simply, where the market is dictating that we should go. I mean, the market for EVs in the U.S. is, it's going to grow, but it's not going to grow at the same pace that we predicted 4 or 5 years ago. So it was very important that, we take that capacity and do something productive with it. And for us, it was very fortunate that we had a lot of experience with different type of chemistries like LFP. And the ESS market is taken off in the U.S. for a number of different reasons, for grid security, grid stability, data centers. And putting those two things together, we were able to convert a significant amount of our plants into LFP projects or LFP cells for ESS projects. And so, yeah, for us, it's been a lot of work, but we're now producing, and most of our plants are up and running. And, I think it's a really exciting kind of advent to the battery industry here.
A real rare win-win for the state of Michigan.
Yeah. How much investment did you have to make to shift from EV to energy storage? And I don't need you to conduct a seminar, but I'm just trying to get a sense of how difficult that is to do in your facilities.
And is it just tooling? Is there training involved? Is there like different skill sets? And what's the main differences between an energy storage battery versus an automotive storage battery?
Yeah. So when you talk about batteries in general, you might talk about different types of chemistry and different form factors. So when we converted from EV batteries to ESS batteries, the biggest conversion was on the chemistry, which went from nickel, manganese, cobalt oxide, NMC chemistry, which is the high energy density chemistry that goes into EVs. From there, we went to lithium iron phosphate. Right, it's not an oxide; it's a LFP iron phosphate. Has less energy density than the oxides, but it has the benefit of being lower cost,
right,
and possibly more safer kind of thermal propagation profile. Right, so we basically had to convert the business into that direction. So what needs to change? Generally, this is getting a little bit technical, but generally when you're making LFP cells, you need to coat the electrodes thicker, right? Because of the energy density. So that sometimes means you need to make some adjustments with your coating equipment. And then the calendaring or the roll press equipment, right? Sometimes you need higher pressure because you're coating thicker. So it really depends on what was there to begin with and what the specs are. But generally, you need to coat thicker, you need to press a little bit more. And those are the adjustments that we need to make. And then, of course, when we get into the cell production itself, there's some parameterization around how you do electrolytes and how you age and how you how you do the formation with the cells, but that's a little bit more subtle. So to make a long story short, there are some equipment in some cases that need to be adjusted so that you can coat thicker or compress. In general, I would say it's not. It might be in the order of 10% of what the total line investment would have been.
And you say adjust equipment, not replace equipment.
Sometimes you would need to adjust equipment. I'm thinking about the line overall, right? Doesn't need to be changed, but there are certain stations along that line that might need to be adjusted. And like I said, I think it depends on what was there first, but you would expect somewhere probably in the range of 10 to 20% to convert from one technology to the other.
The investment that you've made to do this pivot in North America, what's the order of that? Is it tens of millions of dollars, hundreds of millions of dollars?
Well, five of our 8 plants will produce some LFP to different degrees. So I think each of the plants, we're probably in the orders of hundreds of millions of dollars.
Okay.
But if you combine all of it, I think now you're into the billions of dollars.
In billions, okay.
Yeah, if you combine all of the plants.
Okay. Well, obviously you feel like it's worth it. And I'll throw it back to you after this. So what is your outlook for the storage market that you're now addressing in this scaled up way? I guess this kind of corollary to that is, the EV market kind of went up and then it went down, but how confident are you in the durability of demand in the storage market that you're now serving?
Is it the same competitors, and kind of how's the marketing different? How is kind of the customer different?
Well, yeah, so customers are definitely different because in automotive, obviously, you're working mostly with OEMs. Here, you're working with developers. It's a lot more fragmented, right? In the auto world, you have 10 large OEMs around the world.
Right.
In this space, it tends to be a lot more fragmented. I'm sorry, your initial question was?
Well, my question was, what's your outlook for the storage market? And do you feel like it's going to be a more stable, durable market than EVs turned out to be?
So I think, we can project over the next 3 to 5 years. And I think the growth will be pretty stable and robust, at least for that time frame. That's because we're putting more power online in general. We need to manage the power that we have online better by using energy storage to optimize. And then, of course, there's additional demand sources. We've talked about data centers, but other increased manufacturing requirements in the U.S. So there's an overall demand increasing. So if you put all of that together, I do expect significant increase in ESS over the next 4 or 5 years. This is not a political issue. This is not a left or right issue. This is one that could support from all areas of the company, and that's why I think it's going to be a little bit more stable. I think when you look further out, as more and more energy storage systems come online, some of the dynamics may change on how the market behaves, and that's why it makes it a little bit difficult to forecast. Like when everybody has an energy storage system, then the grid stability changes a little bit, right? And then the value proposition for energy storage systems adjusts. So I think some of those changes as the market evolves are things that we're paying attention to.
Right.
But those are kind of outer year things that we can't be certain of. But I would say, for the next handful of 5 years, very stable, politically stable, and so I don't see a huge risk there. In terms of competitors, right? Your last question. So up until now, most of the ESS battery, or a lot of the ESS battery in the U.S. was actually made in China, right? And they were imported in, and
Including Teslas.
Including Tesla. So with investment tax credit, there's various different policies right now where there's federal tax credits if you use local content. So from that point of view, as I mentioned, we were the first ones who produced LFP and moved faster and more aggressively than others. So right now, we're the only ones making this product. I would expect 2 or 3 additional players in the market, let's say within a year. And then, as to, Chinese players and whether they would produce in the market, I mean, I think that's a big debate that we're all, paying attention to, and we don't really have clarity.
But they're not present here now, so.
No.
We mentioned Tesla. You have a pretty significant deal to supply Tesla with LFP for their Megapack business. Is that right?
Yes.
Yeah, yeah. Talk a little bit about that. And is that up and running, or is that still you're still working to launch that?
We're still working to launch that. So we have a really important and interesting relationship with Tesla. So just starting from the automotive side, they produce batteries, right? So in a sense, we compete on the battery side, but we are also a huge supplier to them. I think at one point we were the largest supplier of batteries to them. So we have this competition type of a relationship with Tesla. So when it comes to energy storage, it is similar, right? We provide cells to Tesla's overall Megapack strategy, but then we have LG Vertec, which develops the system solutions based on our cells.
So we should directly compete with the Megapack.
Exactly. So LG Vertec would be competing with would be competing with Tesla.
Right.
So as an LG Energy Solutions cell maker, we kind of have two opportunities, right? Because we will go in with our subsidiary Vertec as a system supplier, and if we win, that's great. If we don't, then we have a potential to work with companies like Tesla and provide cells.
Yeah.
Well, in general, in this business, we would prefer to have the system business. There's a lot more value, and you start getting into when to discharge battery, when to buy power from the grid, and the whole trading strategy and the intelligence that goes behind it creates a tremendous amount of value. And so I think that's why we think there's a lot of value in that. We've invested a lot in that platform, and so we would prefer to work with suppliers or customers with that system solution. But of course, we understand if they want to work with someone else, then
And you're also providing the battery management system
on the LG Vertec system. We do the battery management system, the cooling system. It's a entire fully contained, containerized solution that you put on a platform in desert somewhere. Right? It's fully operational.
Okay.
And it's customized or like a standard?
It's a standard format that we use for all of our customers. So, it would be very difficult to customize that. We purposely, worked with a lot of our customers to get specifications. We've even worked with like CARB in California because they're very instrumental in defining some of these guidelines to understand what's going to be the requirement going forward. And so our product is, meeting that specification. I would say most of the market leaders have probably similar dimensional products because we're all putting containerized solutions outdoors. Okay.
So with all of this, are you looking at hiring additional staff in North America, or is this going to support the existing production, engineering, and related staff that you had hired on to deal with or to manage the EV business that you were anticipating at the start?
So it's combination of both. We have, as we pivot, we've had to develop new skill sets, right, to address the ESS market, different type of customers. There's a lot more maintenance and after service and field service type of activity. Okay. So it's a different setup, right? So of course we've had to hire, those individuals to support that new business. But then, we had a lot of experts in things like BMS on, basic cell chemistry, which, they've been focused more on the automotive industry, but it was relatively easy to shift their focus and have them work on a different type of platform. So it would be a combination of shifting some resources from one part of the company to another, but we also did have to hire up in those areas where it's a new business area. So we're definitely
can you say? And maybe this is a moving target, but can you say roughly how many jobs you've added as a result of the ESS or the storage move?
I want to be accurate about this, so let me try to collect that and get that back to you, because honestly, I know we've hired a bunch of people and I've approved hirings, but I don't have it.
You haven't aggregated, yeah.
Right?
Okay.
Which would be a fair way for me to share that information with you.
So, can you talk a little bit more about the opportunity you see with the data centers? This morning, Andrew Yang was part of the panel discussion, and he said that there's more investment in data centers in the United States than there is in office building space. So that seems like a tremendous opportunity. Can you talk a little bit more about how you're going to address or try to attack that opportunity?
Yeah, so we're supporting several different segments right now. The grid stability and grid optimization is the bigger part of the market, right? So these are utilities who are putting in large-scale energy storage systems to manage their load and work off of their existing generation capabilities. We expect by 2030 that the market will kind of flip, and the data center market's actually going to be about the same size,
Okay.
which is huge, right?
Yeah,
It's a very large
it's a
market.
big market.
So yeah, we expect that market to grow, and
Not in my backyard, though.
Yeah.
well, so I think
Right.
even today, as a lot of people are talking about, I think some of these policy things need to be worked out, and we need to understand how to do these things without impacting water, without impacting power in the communities that they go into, so that you don't have this political fallout. I don't think there's much of an option to not do these things if we want to, continue to lead with high tech and AI. I know, you can have debates on is it too concentrated or not, but I still think at the end of the day we need to compete and continue with our technology leadership, and then I don't know, we figure out as a society how that's structured. But without having that leadership, I don't think you have a lot of options.
Question though, but I mean, I think my understanding is that one of the objections to the data centers is that their backup, that depending on what technology you use, the backup power, if it's like a diesel peaker or something like that, can be noisy, stinky, dirty.
Yes.
Does an energy storage system using one of your battery arrays, does that replace a dirty, stinky, noisy system? Is that a way for the data center operators to say, okay, fine, we're going to mitigate this complaint about the way we do business?
And or does it put a ceiling on energy costs or rising energy costs?
So normally the way they would set up the backup system is actually using combination of both.
Okay.
So the battery UPS, and there's a couple different types of energy storage systems, but the UPS system for data centers, it needs to, if there's a outage, it needs to be able to supply that power instantaneously at a very high C rate, right? So you're not like sustaining this for a long time, but you need to be able to inject a lot of power very quickly, right? And you're only doing that until the generators turn on.
Oh,
Right.
okay. So you still need the generators.
Yeah, so you're just covering that moment, and the chart and the batteries to just have a injection of power while the generator. Now you could set up a system where it's all batteries, right? But then you would need a huge battery,
A lot of batteries,
and I'm not sure if that's a cost-effective solution.
Okay.
Right?
Well,
So
it's good to understand.
yeah, so
Learn something new.
Yeah, we did.
so
All right.
you know what we mean when we say high C rates?
No.
So C rate is a natural way that energy is distributed from a battery. So think about it as a faucet, right? If you have a bucket of water and you have a normal faucet that drains, it might be 1 C rate, right?
Okay.
But if you have a huge faucet that drains the whole thing at 2, 3, 4 times the normal one, you'll call that like a five times C rate. It's like a huge discharge, right? So when you have a high C rate battery, you have a battery that's basically discharging all that power at a very fast rate.
Oh, so the C.
Yes.
I understand
Charging
that,
and discharging.
but it's
When you're discharging at a high C rate, you're giving up the power in the battery very quickly, right? So that's the key element for that UPS function. You need a different chemistry, you need different products. So usually, if you have that plus the diesel, that's the best economic.
that's the cost-effective solution at this point.
So the dirty, stinky, loud is going to be
Still an issue. Well, yeah, we'll
You
introduce.
can minimize it, and then there's other things you can do, but usually, I don't know. I mean, you have to do some data analysis, but usually when things go down, they're not down for that long.
Right.
Yeah.
So when they say dirty, stinky, I mean, if it's going for a couple hours, I don't know if if that's a deal breaker.
The point is, this is not a magic bullet to eliminate that issue. So we can put that as. I'm wondering, as I hear you outline what you've done, especially the shift to LFP. LFP is popular in the EV market, right? I mean, it's become
outside of the U.S.
outside of the U.S. But you now have LFP. I understand it's for a different configuration, but you have LFP now inside North America. And I'm wondering, so these are two related questions. One is, how difficult how difficult would it be should EV demand kind of bounce back, which it might, or automakers say, you know what, LFP, it's a great technology, we want to use that. Could you serve with LFP from this base that you're now building EV demand?
So one, yes, I think there probably you would need different tooling because the size of the cells typically are different between an EV and an ESS cell. So you might have similar chemistries, and we would be able to convert that to an EV-oriented product, but probably at a different size. Right. But before I go there, though, I want to say, we're working on several different lower cost solutions with the major OEMs.
For batteries?
Yes.
EV batteries?
Yes,
okay.
EV batteries. So I think, we have very strong partnerships with GM and even Ford. I mean, we have joint ventures with them still. And, so one of the reasons we focused on high nickel NMC was because that's what the customer demand was. They wanted very high energy density cells. Now we realize we need to look at more affordable solutions, right? So we're working with them on what we call a mid-nickel chemistry, for example. That would be a 60% nickel, not 90%, because 622 configuration or 613. GM's been out there talking a lot about LMR, right?
Right. Yeah. Okay.
Nickel, so it would be manganese without the cobalt, right?
Okay.
And so we're their main development partner on that.
Okay.
So I would say LFP is there, but we're also looking at LMR. We're looking at NMC mid-nickel. And at least for the U.S. market, jury is still out in terms of which of those formats are going to be the sweet spot. I think a lot of companies are trying to figure out, between a premium model and a affordable model, what the configuration is going to look like. But I think for us, we're ready across all of those different dimensions because we're doing ESS for LFP. We have a lot of experience with high nickel NMC. I believe right now we're taking the lead in working with these OEMs and developing lower nickel content. So I think we're definitely working toward an affordable solution, and whatever it is that hits the sweet spot, I do feel we're going to be well positioned.
Just don't work on it.
The county is very bullish on LMR.
I know that.
But
you hear, but you've heard, right?
Well, we're their main
I
partner,
understand.
so we're obviously working with them on it.
I should know this, so forgive me, Bob. Does LG also make chargers and charging stations? And, are you working towards 5C, 6C, 7C charging stations as well?
So we're not directly involved in the charging station business. That was an area, actually, LG Electronics, which is like a sister company of ours. They were in the charging, charging station business. I think they exited the market a couple of years ago. Oh. So at this point, none of LG's companies are working. We do charging stations. What's interesting is, though, in this ESS business, we're working with charging station infrastructure companies like ABB and others, because they're also trying to figure out how to put a modest-sized ESS system in a charging station environment.
Sure.
Right?
Yeah.
So we're definitely working, on infrastructure with those guys, but we're not making the chargers themselves.
Okay, because BYD, as you probably know, has a mega charger.
Yeah.
They want to put a solar panel over the top of it and then have a battery, so it's not pulling from the grid all the time.
Right.
Because mega charger is 1.5 megawatts or whatever.
Well, and to your point about fast discharge of the battery, right? So I have one last question, and two, you may have one too. And I probably tried to swat at this a little earlier, but I'll come back to it. So as you look now at the book of business that's coming in, both from the EV side and also now the energy storage side, and you said you have what, five plants in North America. 5 plants in North America?
8 in North America.
8 in North America. Okay.
7 in the U.S., 1 in Canada.
7 okay. That's a lot. But as you look at the potential business coming in, do you think you might need more? Or do you just have you have the room you need and the capacity you need to serve what you see coming in with the footprint you already have here?
Let me drill down on that a little bit because Kevin Zerzin or Greg Zerzin had talked about let's make this a demand-driven economy for clean energy vehicles or ICE vehicles. But we see that Rivian's coming out to R2.
We're supplying them.
Right. And so the Bolt is coming out, the Equinox is already here. So there are some affordable cars with more on the way. So are you going to be able to go back and forth between energy storage and EV batteries pretty easily, pretty seamlessly? Is that kind of?
Well, I think we can go back pretty seamlessly. That's not the issue. I think the question is just in terms of the EV demand. How does it come back and when does it come back?
Well, yeah, and I guess I mean my question was more like the footprint of manufacturing that you have in North America. As you look out, do you see that that's going to be adequate, or is there a possibility that you might have to want to add an additional facility wherever? Because you've got so much energy storage demand and potentially additional EV demand.
So I think when we designed all of these 8 plants, each of them were designed for 40 to 45 gigawatts of capacity. So that's 300 gigawatts of capacity from a building point of view. That can support 3 million EVs.
Okay.
Right? 100.
So a lot.
So it's a lot of capacity. So I would say, if you're talking about just the building footprint, I would say we have significant amount of capacity that we can fill for the next 5 years. So what we've done is, when we went in, we put the building up. As we started installing all the manufacturing lines, we were a little bit more judicious based on what the demand was and what was happening in the market. So there are parts of the the plant that's still not fully installed.
You have floor space.
So so I think it'll be a while before additional building space is required.
Okay.
I think there's a lot of growth plans for the next 5 years where we have to put in additional lines, and we have plans for that. But I think the infrastructure will be okay. And if you do a little bit of research on the industry overall, right? So I just talked to you about my LG's capacity.
Right.
I think if you look at the overall market, we're talking about, I said 320 gigawatts for us, right? I think building-wise, there's terawatt of capacity in the U.S. building-wise.
Okay.
Building-wise, right? We're like 30%, 35%.
Right. So
a terawatt of building space out there.
Yeah.
So
we're not using a terawatt of batteries yet.
Yeah. So when will we start needing that or needing new buildings? I think it's going to be a little while.
Okay.
The last question I'll ask is, with all this potential capacity that you have, how much are you looking at advanced manufacturing and automation to kind of be more efficient with some of that space?
Battery manufacturing is pretty advanced to begin with, right? I mean, there's a lot of automation. You have to really control the parameters, right? It's not only mechanical. You have to control temperature. You have to control humidity. So it's a multi-dimensional, right? If you're just doing mechanical, that's just 3 dimensions, right? But now you're adding other, right? So it's a very complex automated process in order to control. So I think that was kind of built into the original design. It's I would say it's a highly advanced manufacturing process, very different from manufacturing facilities from the past.
Well, Bob, thank you very much for your time.
Yeah,
All right.
Appreciate it, and hope we can check back with you as all this evolves.
All right, thanks a lot. I appreciate it.
Right.
Thank you.
Thanks, Bob.
All right, thank you.